Hello everyone and welcome again to my How To Education channel. As I promised you last week, today we are gonna start with the chain rule of derivatives. After watching this video, don't forget to leave me your feedback. If we go back to the last two lectures, which were the product rule of derivatives and the quotient rule of derivatives, we can see that in all the exercises and examples given in which we had to find the derivative of a certain polynomial raised to a certain power, the polynomial was always a first degree polynomial and the constant of x was always 1. That is, we never had to find the derivative of 42 plus 2x to the power 14, in which the constant of x is 2, which is different from 1, or even the derivative of x cubed plus 7, all of it squared, in which x is raised to the power of 3, which is different from 1, for example. The reason for always dealing with power 1 and constant 1 polynomials raised to a power is the fact that if the power and the constant of x are different from 1, we have to apply a new rule called the chain rule of derivatives. Let's suppose there is a function f of x such that f of x equals ax plus b, all of it to the power n, in which x is the variable and a, b, and n are constants such that a and n are different from 1. In this case, according to the chain rule of derivatives, the derivative of f of x is equal to the main derivative multiplied by the derivative of the expression inside. Thus, f prime of x equals n times ax plus b to the power n minus 1 times a, which is the derivative of ax plus b. Thus, f prime of x equals n a times ax plus b to the power n minus 1. Let's now suppose that there is a function f of x equals ax to the m plus b, all of it to the power n, such that x is the variable and a, b, m, and n are constants and a, m, and n are different from 1. In this case, f prime of x equals n times ax to the m plus b, all of it to the n minus 1 times x to the power m minus 1, which is the derivative of ax to the m plus b. Thus, f prime of x equals x to the power m minus 1 times ax to the m plus b, all of it to the n minus 1. Let's solve the following examples using the chain rule of derivatives. F of x equals 5x plus x squared, all of it to the 8, such that 5x plus x squared is greater than or equal to 0. If f of x equals 5x plus x squared to the power 8, then f prime of x equals 8 times 5x plus x squared to the power 7 times 5 plus 2x, which is the derivative of 5x plus x squared. So, f prime of x equals 8 times 5 plus 2x times 5x plus x squared to the power 7, which is 40 plus 16x times 5x plus x squared to the power 7. Another example, f of x equals 2 plus 3x to the power 10, such that 2 plus 3x is greater than or equal to 0. If f of x equals 2 plus 3x to the 10, then f prime of x equals 10 times 2 plus 3x to the 9 times 3, which is the derivative of 2 plus 3x. Thus, f prime of x equals 30 times 2 plus 3x to the 9. In order to make sure that you grasp the chain rule, I would recommend that you pause this video and try to solve the following exercises before I give you the solutions. f of x equals 4 minus 3x to the 6, all of it to the power minus 9, such that 4 minus 3x to the power 6 is different from 0. The given function is of the format a times x to the power m plus b, all of it to the power n, such that b is 4, a is minus 3, m is 6, and n is minus 9. Thus, its derivative follows the general format f prime of x equals n times m times a times x to the power m minus 1 times ax to the power m plus b, all of it to the power n minus 1. So, if f of x equals 4 minus 3x to the 6, all of it to the power minus 9, then f prime of x equals minus 9 times 4 minus 3x to the 6, all of it to the power minus 10, times minus 18x to the 5, which is the derivative of 4 minus 3x to the 6. Thus, f prime of x equals minus 162x to the 5 times 4 minus 3x to the 6, all of it to the power minus 10. f of x equals 5 plus 7x to the power 1 over 3. This given function is of the format f of x equals ax plus b to the power n, such that b is 5, a is 7, and n is 1 over 3. Thus, its derivative follows the general format f prime of x equals na times ax plus b to the power n minus 1. So, if f of x equals 5 plus 7x to the power 1 over 3, then f prime of x equals 1 over 3 times 5 plus 7x to the power minus 2 over 3 times 7, which is the derivative of 5 plus 7x. Thus, f prime of x equals 7 over 3 times 5 plus 7x to the power minus 2 over 3. f of x equals 1 over 4 plus 17x, such that 4 plus 17x is different from 0. First of all, f of x can be written as 1 over 4 plus 17x to the power 1, which is the same as 4 plus 17x, all of it to the power minus 1. If f of x equals 4 plus 17x to the power minus 1, we can use the chain rule of derivatives in order to find f prime of x. Since f of x follows the format f of x equals ax plus b to the power n, such that b is 4, a is 17, and n is minus 1, then f prime of x follows the general format f prime of x equals na times ax plus b to the power n minus 1. So, f prime of x equals minus 1 times 4 plus 17x to the power minus 2 times 17, which is the derivative of 4 plus 17x. f prime of x equals minus 17 times 4 plus 17x to the power minus 2, which is the same as minus 17 over 4 plus 17x to the power 2. f of x equals the radical of 13 minus x, such that 13 minus x is greater than or equal to 0. The following function can be written as f of x equals 13 minus x to the power 1 over 2. This means that the given function is of the format f of x equals ax plus b to the power n, such that b is 13, a is minus 1, and n is half. Thus, its derivative follows the general format f prime of x equals na times ax plus b to the power n minus 1. So, if f of x equals 13 minus x to the power half, then f prime of x equals half 13 minus x to the power minus half times minus 1, which is the derivative of 13 minus x. F prime of x equals minus half times 13 minus x to the power minus half. F of x equals 2 times 4 plus 9x to the power 3. This given function is of the format f of x equals c times ax plus b to the power n, such that b is 4, a is 9, c is 2, and n is 3. Thus, its derivative follows the general format f prime of x equals cna times ax plus b to the power n minus 1. So, if f of x equals 2 times 4 plus 9x to the power 3, then f prime of x equals 2 times 3 times 4 plus 9x to the power 3 times 9, which is the derivative of 4 plus 9x. F prime of x equals 54 times 4 plus 9x to the power 3. F of x equals 31x times 40 minus x to the power minus 2, such that 40 minus x is different from 0. The given function is of the format f of x equals g of x times h of x. Thus, its derivative will follow the format f prime of x equals g prime of x times h of x plus h prime of x times g of x, such that g of x is 31x and h of x is 40 minus x to the power minus 2. If g of x is 31x, then g prime of x is 31. If h of x is 40 minus x to the power minus 2, it means that it follows the general format h of x equals ax plus b to the power n, such that a equals minus 1, b equals 40, and n equals minus 2. Thus, in order to find h prime of x, we need to follow the general format of the chain rule. H prime of x equals na times ax plus b to the power n minus 1. Thus, h prime of x equals minus 2 times 40 minus x to the power minus 3 times minus 1, which is the derivative of 40 minus x. H prime of x will equal 2 times 40 minus x to the power minus 3. F prime of x will then equal 31 times 40 minus x to the power minus 2 plus 2 times 40 minus x to the power minus 3 times 31x. F prime of x will equal 31 times 40 minus x to the power minus 2 plus 62x times 40 minus x to the power minus 3. We will be working on new exercises covering the chain rule of derivatives next week. This is it from math for this week, but if you have reached the end of this video, it is because the content is helpful to you somehow. If this is the case, then don't forget to give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with more exercises about the chain rule of derivatives next Monday. But before that, I will see you all on Wednesday with some economics content. Thank you so much.